All right, so this next portion, let me put my calculator back up here. This next portion continues on when it comes to our limits, but we focus on portions of it. So this first portion is talking about our one-sided limits. So we kind of already looked at it a little bit, but we didn't really call it what it was. But one-side limits pretty much one deals with the right side, one deals with the left side. If you have the positive sign right there, oh, sorry, move this positive. So if you have a positive sign right there, that means you're looking at coming from the right side to that whatever number that is there. So for example, if this was x approaches 2 with a plus sign, you come from the right side of the graph and you go to the number 2. If this is the left side here, that means it's a negative sign up there. So that means you're going from the left side of the graph and coming to that number and looking at what value the y value is going towards. Right, so with this, we're going to take a look at another example here to make sure you can see visually what we're talking about. And then we're going to go from there. So here we're going to use the graph to the right. And I'm going to cover that up right now. You can see that. So we're going to look at this graph to the right over here. And we're going to find the following two, A and B. So we know first off, when it comes to A, the negative means left. So we come from the left side for A. And then the positive means right. So that means we're going from the right side here. Okay. And we're taking a look at when x equals 3 and when x equals 5. So starting off with x equals 3, I'm going to put a dotted line right here. So we know this is our x equals 3 portion. And as x approaches 3 from the left side, so we come from this direction, going over to x equals 3, what is our graph going to for the y value? So as x approaches 3, what y value are we getting close to? Hopefully you're saying 8 right there, because as we come around here, getting closer and closer to x equals 3, it's getting closer and closer to 8. That equals 8 right here. That's what's getting closer. That's what's approaching. All right, when it comes to B, let's do black. When it comes to B here, we say we're going to go from the right side and try to get to 5. So 5 is right here. X equals 5 is right here. And so with this, as we're approaching 5 from the right side, so coming from this side over, we're going to follow this graph exactly as we have it. We're going to come and see as we're getting closer and closer to 5, x equals 5, what is your y value going to be? And it's 5, right? Because as this is approaching, getting closer and closer to x equals 5, your y value is getting closer and closer to 5. It's getting right there. It's going to 5. So as x approaches 5, your y value is getting to 5. Alright, so now I wanted to do this part, and for some reason I didn't add this originally onto the paper, onto the notes. I'm going to add it now. So I'm going to add this other one. Oh, sorry. It's a negative. Alright, so we have for C, the limit at f of x as x approaches 4 from the right side. And then we have the limit of f of x as x approaches 4 from the left side. Again, right because of the positive sign. Left because of the negative. Negative there, positive there. All right, so we're taking a look at the same spot. So here we're taking a look at this line right here. X equals 4. And let me go and take off the other one so it doesn't get confusing. No! Don't do that, don't do that. Go back, go back. Sorry about that, guys. Am I supposed to happen like that? Take these pieces off. So we can just focus on the green one. Okay, so we're taking a look at just the green line. So if we take a look at just that green line, we said that the first one's coming from the right, the second one's going from the left. So if we're coming from the right side and we're going closer and closer to 4, what is your y value going towards? It's going towards 6. So here on the right side, we get 6. Okay, and then as we're coming from the left side and going to 4, that's going to 10. So it's going to 10 on this side, going to 6 on this side. Now, what we're getting ready to talk about, I'm going to give it to you, and then we're going to stop there and go to another video. If these two do not match up, if the right side and the left side don't match up, we're going to say that the limit of the number of 4 doesn't exist, or limit of whatever number is there does not exist. So here, the right side and the left side have to equal each other in order for it to exist. And we'll talk more about that, and we'll hit that more in calculus also. So let's go on to the next page. And this is what I was talking about when I just said that. It says, for a limit to exist, the left hand and the right hand limits must equal each other. And as an example of this, we have this one for 3. If they equal each other, that means the limit as x approaches 3 exists. If these two, like for example, that answers a 4, this answers a 5, that means this limit right here does not exist. So DEN, that means does not exist. So again, if these numbers, these two limits do not equal each other, that means the whole limit does not exist. And that's one of the things we're probably not going to hit really that much in here, but we'll hit it again if you take calculus, or if you go off to college and take calculus, or whatever you do, you're going to see it there. Right, so that's pretty much all we're going to do in these videos, and then now we're going to go into the next portion.